Hey there, welcome to my channel. I'm here with Science Max, and today we are going to simulate a solar storm in this jar of water. It's going to be so much fun. So make sure you subscribe if you don't want to miss out. And let's bring the sun's fury into your home safely. Okay, first things first. You need a strong magnet like this guy. Then you also need a compass. And then you also need some iron filings. Now, all of these things can be found in a science kit. Now that you have all the tools you need to simulate a solar storm, we're going to start by sprinkling our iron fillings around the edge of this jar. Then we're going to place our compass right in the middle, and we're going to turn the power on. Look at that. The compass is already starting to freak out because of the iron fillings. And remember that sunlight takes 8 minutes to reach Earth from the sun. But what about the particles from a solar flare? Well, you'll find out at the end of this episode. Watch what happens as I move my magnet closer to the compass. Does the compass needle twitch? Yep, it does. In fact, the Earth's magnetic field lines get all twisted up when a solar flare hits them. This causes the magnetic field to do crazy things. That's why compasses freak out during solar storms. And people who depend on other magnets, well, they have problems too. For example, every time a solar flare hits Earth, telegraph systems around the world go haywire. That's what happened in 1859, when the first modern telegraph system was turned on. It was so bad that people could send messages by telegraph without even paying for it. The telegraph just worked for free because of all the crazy energy going on. Then again, not everybody was happy about this. Some people were so angry that their free telegraphs weren't free that they started breaking telegraphs. And of course, this led to the telegraph companies starting to charge people again. But that's a story for another time. The thing that causes this is called geomagnetic storms. These happen when a solar flare hits Earth's magnetic field, which surrounds our planet and protects us from the sun. It's made of charged particles, and it extends thousands of kilometers out from Earth. Every time the sun sends one of its super eruptions our way, our magnetic field gets all messed up. Here's how. This is a model of Earth's magnetic field. See how nice and neat those field lines are? It's pretty well. Now watch what happens when I simulate a solar flare hitting the magnetic field. Whoa, those field lines get all twisted up, don't they? That's exactly what happens when a solar storm hits Earth. The magnetic field lines get all jumbled up and charged particles rain down on the planet. Now, if you live in North America, this part of the storm is probably pretty familiar to you. In 1921, a solar storm caused one of the most famous disasters in U.S. history. It happened on a Friday, hence the name. It knocked out the stock market and communications across the country. People couldn't talk to each other or even send telegraphs for over a day. Trains stopped running. Factories shut down. People were stuck in elevators without air conditioning, and people even got lost at sea because ships could uncommunicate with each other. Solar storms have been happening since the beginning of our planet. Our ancestors have been living with them for thousands of years. But the first modern electronics were invented only a couple hundred years ago. As our technology has gotten more advanced, we've become more dependent on devices that are hurt by solar storms. That's why a big one could cause real trouble these days. You know what else depends on the sun? Plants do. When the sun is really active, which means it has lots of sunspots and solar flares, plants grow faster. That's because the extra radiation from the sun helps plants photosynthesize better. On the other hand, when the sun is quiet, plants tend to grow slower. How do scientists know this? Well, because they measured plants in space and compared them to similar plants on Earth. They found that plants near the window grew faster than plants further away from the window. A quiet sun is good news for satellites, though. See, a lot of satellites are made of plastic and metal. When the sun is quiet, that means they don't get charged up very much by radiation. But when the sun is really active, then they can get hit hard. When that happens, the satellites get damaged, and sometimes they even come crashing back down to Earth. How do you measure how active the sun is? Scientists use something called sunspots. Sunspot is a region on the sun that's cooler than the stuff around it. That means that it reflects less light, so you can see it as a dark spot. The coolest part of a sunspot is the umbra, and the stuff around it is called the penumbra. Sunspots usually appear in pairs. That's because they're caused by magnetic field lines that are twisted up on the sun. The twisting makes the plasma in the sun's atmosphere rise up. As it rises, it cools down and forms a sunspot. There are different sizes of sunspots, and scientists classify them based on their size. Small sunspot is a spotless, which is smaller than 10,000 kilometers wide. Most sunspots are between 50,000 and 100,000 kilometers wide, and those are called beta-class sunspots. If a sunspot is bigger than 100,000 kilometers, then it's called an alpha-class sunspot. The biggest sunspot ever recorded was over 274,000 kilometers wide. It's as wide as 86 of the United States lined up side by side. Every 11 years, the sun goes through something called a solar maximum. It's when it's most active and has the most sunspots. Then after the maximum, the sun gets less active until it reaches a solar minimum. We're actually due for a solar maximum in 2025, so we better be prepared. You can predict when the sun will have a solar maximum. How do you do it? By counting sunspots. If you keep track of how many sunspots you see each day, you can make a graph like this. Then you calculate something called the butterfly diagram. If you do it right, you can figure out when the next maximum will be. When the sun is really active, it doesn't just spit out sunspots. It also spits out solar flares and coronal mass ejections. Solar flares are huge bursts of radiation that shoot out from the sun. Coronal mass ejections are giant clouds of plasma. Both of these things can reach Earth and mess up our technology. That's why it's important to track them. To track solar flares, scientists use satellites like the Solar Dynamics Observatory. It takes pictures of the sun all the time and sends them to scientists. Scientists analyze the pictures and give the flare a class depending on how big it is. An X-class flare is the biggest. When a flare hits Earth, it can mess with radio communications and even damage satellites. Luckily, X-class flares aren't that common. Most flares are either A, B, C, D, or M-class. Coronal mass ejections are harder to track because they don't head straight for Earth. Sometimes they go in different directions. Also, it's hard to tell how big they are until they hit Earth's magnetic field. To track them, scientists use a spacecraft called the Advanced Composition Explorer. It flies ahead of Earth in its orbit around the sun and warns scientists when a coronal mass ejection is coming. Solar storms can be dangerous, but they're also beautiful. When the charged particles from a solar flare hit Earth's atmosphere, they cause the atoms in the air to glow. This makes cool patterns in the sky. These glowing patterns are called auroras. Auroras usually only appear at high latitudes, like in places like northern Norway or northern Canada. But during a big solar storm, you might be able to see them anywhere. I think auroras are the best part of a solar storm. What about you? Leave me a comment and let me know. Remember that riddle I asked you at the beginning of the episode? Here's your chance to answer it. If light from the sun takes 8 minutes to reach Earth, how long would it take for a solar flare's particles to arrive? Well, it turns out it takes about 2 to 3 days for the particles to get here. That's a lot longer than the 8 minutes it takes for the light to get here, but it's still pretty fast. Now that you know all about solar storms, you can help keep everyone safe. Make sure you tell your friends and family about all the things that can go wrong during a solar storm, so they'll be prepared to. If you liked this episode, make sure you hit the like button. And don't forget to subscribe. Thank you for watching. I'll see you next time.